Good morning, everyone. So my PhD research focuses on developing innovative software engineering methodologies targeting the interactive service robotics setting. So the main motivation behind this work is the fact that personal care robots are entering the service sector. So you can imagine scenarios and settings ranging from healthcare to retail to domestic assistance. So in these settings, the problem is that robots will interact with a wide variety of people, so with very different needs, very different features, and this constitutes a big issue and a source of uncertainty. And with currently existing software development practices, they allow us to program robots to prioritize efficiency, so time management, battery life management in a very efficient way. But you can imagine that you are sick, you are in pain and discomfort, and you have a service robot at your service, so a personal domestic assistant. With currently existing techniques, this robot will be programmed to act like a very efficient machine, but in this situation, you will probably rather have a loving friend that prioritizes your well-being by your side rather than a machine. So the vision that this work fosters is that in the future, robots will be programmed to actually account for our well-being, so our emotional and physiological state. They will be able to foresee our action, foresee our behavior, and actually assist us in our everyday life. So the solution that we propose to actually achieve this goal is a software suite, so a collection of software products that allow us to perform the following actions. So the tool is actually meant to be user-friendly, so every one of us will be able to design the robotic task, so what the robot is actually meant to do. And the innovative aspect of this phase is that we will be able to specify physiological and behavioral features of the human subjects the robot should interact with. Then it will be possible to deploy the application either in a realistic setting, so either in a physical setting or in a simulating environment with realistic physics engine, and this is meant to be compatible with multiple robotic platforms. The data collected by actually executing the application is fed to an artificial intelligence technique that has been developed for this project. So this technique is actually able to infer a model of human behavior and human actions from the data, and this newly accumulated knowledge, so the updated model, is then exploited to refine and adjust robotic tasks if this is found to be necessary to prioritize and improve the physical and mental well-being of the subjects during the interaction. And this is currently a TRL4 state of advancement. So as you can imagine, this work impacts society in many different ways. First and foremost, we are an aging society, so the demand for healthcare services is ever increasing, and it is found that the healthcare sector has not been able to scale to this increasing demand. So entrusting robots with tasks that are currently performed by human workers can improve the quality of services and quality of life. Then, as I said earlier, the tool is meant to be accessible to a wide audience, so this can lower the technological barrier between the people who have to develop the robotic task and the tool that allows us to do this programming. So ultimately, in the long run, it is envisaged that there will be professional figures actually in charge of developing and maintaining these robotic tasks in service facilities, so this can shape the job market of the future. Then clearly, as you can imagine, since we are embedding human-oriented factors into the software development process, this can help improve people's acceptance of robots, so increase the trust between the human and the robot. And last but not least, the service robotics sector is currently estimated to be worth $24 billion, so even with 1.8 million of potential targets for domestic assistant robots, we're looking at several tens of thousands of units sold. So this can create many economic opportunities. This is the team working on this project. So there's me and two professors from the Department of Electronics and Department of Mechanics, and we are all affiliated with the DeepC research group. Thank you very much.
Ciao, Livia. One question. You said that you're developing a set of software tools.
Yes.
And you also mentioned that you are TRL4.
Yes.
So why? Okay, it's a piece of software. What kind of development you need to reach in which specific part of
So we have tested the software toolchain, so the different phases that I described, which constitute the development toolchain. We have tested it in, let's say, in a simulation environment and in the laboratory, which is in our office, with a real robotic platform. So with in a digital twin paradigm setting. So. With a real robotic platform, performing the design task, interacting with stimulated humans.
Okay, thank you again very much.